Good morning. Welcome to our MCA review. You'll be having your MCA in a little over 2 weeks. So what we are going to do from here on out until then is we're going to do a little review of things we've learned over the year and a couple of things that we haven't. So we're going to put two topics into one. The first thing we're going to do is talk about scientific notation. Now, scientific notation is something we haven't done yet, so we're going to quick learn it. Now, using scientific notation, so it says a number is written in scientific notation if it has the form c, where c is a number, times 10 to the nth power, where c is greater than or equal to 1, and or c is less than 10, and n is an integer. So c has to be greater than or equal to 1, has to be less than 10, and n is an integer. So this n would have to be a number. This c would have to be a number that is greater than or equal to 1 and less than 10. Now if we have a standard form, 325,000, we can write this in scientific notation as 3.25 times 10 to the 5th. Now what we do, or how we do that, is we imagine that there is a decimal point right there. It's just imaginary, and we could go 1, 2, 3, 4, 5 spots and put a decimal point there. We're always going to put a decimal point after the first number. So right now we have 3.25 times 10 to the 5th power because we went over 5 times. Now when we have a smaller number like this, we're going to have a negative exponent. So this is 0.0005. That's written as 5 times 10 to the negative 4th power. So just like we did at the last one, we are going to take our decimal and we're going to move it over 1, 2, 3 spots, 4 spots until we get right after our number. Now we have 5 to the negative 10 to the negative 4th power. So when we have positive exponents like this 5, we're going to have big numbers. When we have negative exponents like this negative 4, we are going to have very small numbers. So let's try a couple. Here we have the standard form, 405,000. What we're going to do is we are going to pretend there's a decimal point right here. And we are going to go until we get it after our first number. So 1, 2, 3, 4, and 5. So we went over 5 spots. We could put our decimal right there. So we get 4.05 times 10 to the, now we count up how many spots we went, 1, 2, 3, 4, 5, so 10 to the 5th power. Down here we pretend there's a decimal right there, and we go over 1, 2, 3, 4, 5, 6 spots. We're getting right behind that first number, so we get 6.31. Now you don't need to write these zeros after it because this is basically saying that there's zeros after everything in our decimal. So 6.31 times 10 to the 1, 2, 3, 4, 5, 6th power. 10 to the 6th power. Now if we're given the scientific notation, we have 7 times 10 to the 2nd power. We need to write a 7, and we need to write 2 zeros. That's what it means by 10 to the 2nd power. So 10 to the 2 0 gives us 700. Now, if we have 3.484, we write 3484. And we have 10 to the 8th power. So we take our decimal from here. We're going to go 8 spots. 1, 2, 3, 4, 5, 6, 7, 8. Now those spots that we don't have anything, we can just fill in with a 0. So 0, 0, 0, 0, and 0. So what we have now is 348,400,000. An easier way to write that then is 3.484 times 10 to the 8. Now down here we have small numbers, so numbers that are less than 1. So they're going to have negative exponents. So what we're going to do again is count until we get behind our number. So 1, 2, 3, 4, 5. So that, if we put our decimal point there, is 5 times 10. Now it's a less than 1, it's a small number, so we have a negative exponent. 1, 2, 3, 4, 5. So 10 to the negative 5th power. Here we are going until we get behind our first number. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And put a decimal point there. Then we have 6.301 times 10 to the 1, 2, 3, 4, 5, 6, 7. Negative 7th power. 6.301 times 10 to the negative 7th power. Our next one, we have 7 times 10 to the negative 2. So this time we're going to write our 7, but it's negative, so we need to go backwards. 1, 2. So we have a 0 there and a decimal point there. So what we have is 0.07, or 0.7 hundredths. Here we have 3.106 times 10 to the negative 8. So what we can write is 3.106. And this is like saying that we have a decimal after our first number. So we're going to go back 8 spots. So 1, 2, 3, 4, 5, 6, 7, 8. And put our decimal point there now. Now every hump that we don't have any number, we can put a 0. So 0, 0, 0, 0, 0, 0, and 0. So this is a very small number. It's got a lot of zeros in front of it. But that is 3.106 times 10 to the negative 8. Alright, so the next one, we are looking for the number of the value 1.728 times 10 to the 6th over 5.4 times 10 to the 8th. So what we're going to do is we are going to subtract our exponents. So 6 minus 8 gives us negative 2. So we need to look and see if we have any of our exponents as negative 2. Not here we have 3, not here we have negative 3, not here we have negative 1, but this last one we have a negative 2. So we know that this has to be our answer. Here we need to figure out which list shows the numbers in order from least to greatest. So we know that a least number is going to be a negative, so we need to look for negatives. They all have negative numbers, but this one only is going back 2. So we know we can cross off this one. It's going to be one of the negative 3s. Now if we're going up from least to greatest, we know we can have we know that our least one is going to be a 3.5 because 5.3 is bigger than any of those. So we know that it's going to be either B or C. So we can write these out if we wanted to. So this is 3.5 times 10 to the negative 3. So we could have 3, 5 times 1, 2, 3. So both of these are going to have 0 like that as our first one. The next one says, for B, says 3.5 times 10 to the negative 2. Go over 1, 2. So we get 0.035. This one we have 5.3 times 10 to the negative 3. So 1, 2, 3. Okay, so both of these are greater than 0.0035. So we're still not out of the woods yet. We need to figure out our last one. Our last one has a negative 3 on it. This one has a negative 2. So we know that the negative 2 has to be the greatest. So we can cross out B. And our answer then would be C. Alright, so we did our first scientific notation lesson. Now we are moving on to our next lesson, which is slope. So, just some words that have to do with slope that we're probably going to need to remember. Rate of change, that's what slope is, it's the rate of change. Rise over run, that's how we find m. Slope is the rate of change. Domain is the x values. Y-intercept is where the line crosses the y-axis. Y equals mx plus b is slope-intercept form. X-intercept when the line crosses the x-axis, and we're just going to be graphing them. Again, we have slope man. Positive is going uphill, negative is going downhill. Straight up and down is undefined. Side to side is 0. We have rise over run, or y2 minus y1 over x2 minus x1. Alright, first thing we need to do, find the slope. So what this form of equation is y equals mx plus b. We know that our m is slope, so our m has to be negative 5. Here we're finding the rise over the run. So 1, 2, 3, 4, 5. We know we're going up 5. And over 1, 2, 3, 4. So the slope is 5 over 4. Our next problem, we need to find the slope with our equation. So y2 minus y1 over x2 minus x1. Now if these are x and y, our first x is going to be x1, our second x is x2, first y is y1, our second y is y2. So our y2 is 6, so 6 minus our y1, which is negative 2. Then we have negative 3 minus our negative 3. So we can create these, or make these into positives. So 6 plus 2 is 8. negative 3 plus 3 is 0. So our slope here, our m, 8 divided by 0 is 0. So our m is 0 for this one. Our next one, we need to get y by itself. So what we're going to do is subtract our 7x because it's positive to the other side. And what we get is negative 5y equals negative 7x minus 25. To get y by itself, we divide by negative 5. So our answer then is y equals, two negatives make a positive, but 5 doesn't go into 7, so we're going to make a positive 7/5. Plus, two negatives make a positive, 25 divided by 5 is 5. So our m, remember, is right here. So our slope then is m equals 7/5. Next problem, our line is going downhill, so we know it's going to be negative. Our m is going to be negative. So we're going down 1, 2, 3, 4, 5, 6. Down 6 over 1, 2, 3. Now we can simplify it, negative 6 over 3 to just m equals negative 2 because we divided each by 3, which would give us negative 2 over 1, or just m equals negative 2. Over here we are going to have an x1, a y1, an x2, and a y2. So we know our y2 is 4, and our y1 is 9. We know our x2 is 0, and we know our x1 is 6. So 4 minus 9 gives us negative 5. 0 minus 6 gives us negative 6. Two negatives make a positive, so positive 5 over 6. That's how we find slope. So let's go on to a graph then. Alright, so first of all, we are going to plot and label these following points. So, negative 3, 1. We know that the negative 3 is our x, and the 1 is our y. So we're going to go over to negative 3, 1, 2, 3, negative 3, and up 1. So this one we're going to the left and up. Here we're going to go to the right, positive 2, and up 3. So first of all, let's label this A. So we're going to go to the right 2 and up 1, 2, 3. Then this is B. Then we're going to go to the right 4. And now we have a negative, so down 3. So 1, 2, 3, 4. And down 1, 2, 3. And this is C. And our last point is negative 4, negative 4. So to the left 4 and down 4. So 1, 2, 3, 4, down 1, 2, 3, 4. And that's D. So what we need to do now is find the slope of each side of our quadrilateral. If we would connect these, we would have a quadrilateral, which means 4 sides. So what we need to do is find the slope of each of those sides. So here we are going from A to B. So from A to B, we're going to go up 1, 2. So our rise is 2. Our run then is 1, 2, 3, 4, 5. So our slope from A to B is 2 over 5. From B to C, we're going down, so it's going to be negative. We're going down 1, 2, 3, 4, 5, 6. So negative 6 over 1, 2. Negative 6 over 2 can be simplified to negative 3. Now we're going from C to D. We're going downhill again, so it's still going to be negative. Well, the top is going to be negative 1. And the bottom, we're going backwards, so it's going to be negative as well. 1, 2, 3, 4, 5, 6, 7, 8. Negative 8. 2 negatives make a positive. 1 over 8. And finally, we have a uphill from D to A. Up 1, 2, 3, 4, 5. Over 1. 5 over 1, or 5. Alright, now we've completed day 1. This was scientific notation and slope. So you can either continue on to day 2 or just get your worksheet for this one and call it good for the day.